A pleasant morning to the dear learners. Today I shall be handling correlation from Statistics 2. I am Dr. Shobha Edward, Principal, Associate Professor and Head of the Department of Corporate Secretaryship, KCS Kasinada College of Arts and Science, Chennai 21. Now, what is correlation? The relationship between two series when measured quantitatively is known as correlation. Correlation is a statistical technique which shows the relationship between two or more variables. These variables may be price and supply, income and savings, etc. Types of correlation: positive and negative correlation. Positive correlation: if two variables are varying in the same direction, that is, when one increases, the other also increases, it is called as positive correlation. Examples: income and expenditure. Negative correlation: if two variables are varying in the opposite direction, that is, when one increases, the other decreases, we call it as negatively correlated. Example: price and demand. The other types are linear and non-linear correlation, simple and multiple correlation. Simple correlation: when only two variables are involved, it is known as simple correlation. When there are more than two variables that are involved, it is known as multiple correlation. Example: income, savings and investment. Methods to calculate correlation. Correlation can be measured graphically, for which we have the scatter diagram. It is the simplest method of checking whether two variables are correlated. In this method, the given data are plotted on a graph sheet in the form of data. Mathematical methods: we have Karl-Pearson's method, Spearman's method and concurrent deviation method. So now moving on to Karl-Pearson's method, where we have a direct method and a shortcut method. So in the direct method, there are two types. I move on to the second type. R is equal to sigma dx dy divided by root of sigma dx squared into sigma dy squared, where dx is equal to x minus x bar and dy is equal to y minus y bar. Now going on to the shortcut method, where we do it from the assumed mean. Dx is equal to x minus a and dy is equal to y minus a. R is equal to sigma dx dy minus sigma dx sigma dy divided by n, the whole thing divided by root of sigma dx minus sigma dx by n the whole square into root of sigma dy minus sigma dy the whole square by n. Spearman's rank correlation. So when you go on to the Spearman's rank correlation, we have the ranks that are being considered. So this is applied for quantitative variables. We have the Karl-Pearson's method, and for qualitative items we have the ranking, that is for beauty, honesty, etc. The ranks are used. When ranks are not repeated, R is equal to 1 minus 6 sigma d squared by n cubed minus n. And when ranks are repeated, it is given by the following formula. R is equal to 1 minus 6 sigma d squared plus 1 by 12 m cubed minus n plus 1 by 12 m cubed minus m plus 1 by 12 m cubed minus m, and so on, the whole thing divided by n cubed minus n, where m is the number of repetitions of ranks. Concurrent deviation method. It is the simplest of all methods used. It is used to know the direction of change of the x and y variables. Importance of correlation. It helps to study the type of association. For example, we could know the relationship between price and demand. It helps to find the exact degree of correlation. It also helps to know if the correlation is significant or not. By applying the technique of probable error, we would find whether the correlation is significant or not. It helps us to estimate the future. As the price and demand are directly related, an analyst can foresee the demand with the help of correlation. Scope of correlation analysis. It helps in tackling economic problems. Example, prices usually rise due to rise in money supply. Correlation is used in analyzing whether the price rises due to money supply or any other factors. It is used in research. It is also used for making further research in economics, and many new laws are also developed. To test economic laws, it is used to test whether a law is valid or not. Flow of demand. With increase in price, demand decreases and vice versa. Thus, a correlation exists between price and demand, and hence the law is correlation. To form new policy, it helps the government to keep the price index under control by making it proportional to change in money supply. So now we shall move on to some simple problems. For example, find the correlation from sigma dx dy, sigma dx, sigma dy, sigma dx squared, sigma dy squared, and n. So we just have to substitute these values in the formula where you have sigma dx dy, sigma dx, sigma dy, n, sigma dx squared, sigma dy squared. You just have to substitute those values and come to the answer. There is one more simple problem where n is given, x bar is given, y bar, sigma x minus x bar the whole square, sigma y minus y bar the whole square. So in this occasion, we use this formula where the given values can be easily substituted. So R is found by applying the formula and substituting the given values. Now going on to Karl Pearson's coefficient of correlation. So one example where x values and y values are given. So we have taken the x values, the y values. So now we are supposed to find dx, dy, dx squared, dy squared, dx, dy. To find dx, we are supposed to be doing x minus x bar. So first we find x bar. X bar is nothing but sigma x by n. So the total of x values divided by the number of values, we get x bar as 6, and similarly y bar as 8. So from every x value, we have been subtracting the x bar and we have arrived at dx. Similarly, from every y value, we subtract y bar and we arrive at dy. Now dx, the values in dx are squared, so we get dx squared. The values in dy are squared and we get dy squared. Now dx and dy are multiplied to arrive at dx dy. So now that all these columns are complete, we take the total of dx squared, dy squared, dx dy, so that we can substitute in our formula r is equal to sigma dx dy by root of sigma dx squared into sigma dy squared. On substituting the values, we arrive at r. Now this is rank correlation, Spearman's rank correlation, and ranks are given to us. So here we have x values, the y values, so they are considered as rank 1 and rank 2. So when you have rank 1 and rank 2, we are supposed to first find d. d is nothing but rank 1 minus rank 2, and d squared is the square of d. So here rank 1 is 5 minus 4, which results in 4. So rank 1 minus rank 2 is d, and while squaring we get d squared. Now going to our formula, we need this total of d squared. So our formula for rank correlation, 1 minus 6 sigma d squared by n cubed minus n. So d squared, the total of d squared is 40. So we substitute 1 minus 6 into 40 by 5 values we have, 5 cubed minus 5. So our rank correlation is arrived at. Now here, ranks are not given to us. So when ranks are not given to us, it is up to us to find out the ranks. So here, going on to our column, we go in. The first rank is 42, so 1. The second rank is 37, so 2. The third rank is 36, 3. The next rank 25, which is 4, and the next one 21, which is 5. So rank 1 is written. Similarly, rank 2 is also written using the Y column. Now, the usual procedure, D is equal to rank 1 minus rank 2. 5 minus 1, 4. And D squared, 4 squared is 16. And as usual, you substitute in your formula and arrive at your rank correlation. Now, we go on to a situation where ranks are repeated. So here we have our ranks which are actually found out by us. The values are given to us. So our first rank is 65. Then we have the second rank, which is 57. The third rank, which is 48. The fourth rank, which is 40. The fifth rank, which is 33, and so on. But when you go further, the sixth rank is here, and then the seventh and eighth and the ninth rank is same. You have 16, 16, 16. So when it is 7, 8 and 9, it is 7 plus 8 plus 9 divided by 3. So the rank is 8 for all of them. So now that you have written the 6th rank and the 7th, 8th and 9th rank is over, you move on to the next one as 10. So the ranking is done, ranks are repeated. Same way, while going to the next column, again for the ranks, we have the first rank, we have the second rank, we have the third rank, we have the fourth. But when you come to the fifth rank, we have two similar values. So the fifth and sixth rank are the same. So 5 plus 6 by 2, which is 5.5. So the fifth and the sixth rank is over. So the next is the seventh rank. And then we go on to the eighth one. The eighth rank again is similar, 8 and 9. So 8 plus 9 by 2. So it is 8.5, 8.5. So now 8 and 9 is also over. So we go on to the next one, the 10. Now as usual, we have rank 1, rank 2. So D can be found by rank 1 minus rank 2, and D squared, the square of D values, get the total and go on for substitution. Here M is the number of repetitions. So we had 8 over here 3 times. So when you write, it is 3 cubed minus 3. And then we had 5.5 2 times. Twice we had 5.5. So it is 2 cubed minus 2. And then we have twice 8.5. So again another 2 cubed minus 2. So M is nothing but the number of repetitions. On substituting, you can solve the formula and arrive at R. The usual one where you have the judges. There are 3 judges in this question where they want us to find the similarity in taste among the judges. So here it is again rank correlation. Ranks are given to us, but what we have to do is we have to do D for rank 1 and rank 2, D2 for rank 2 and rank 3. So rank 1 and rank 2 is D1, rank 2 and rank 3 is D2, rank 1 and rank 3 is D3. So on getting the differences, it is rank 1 minus rank 2. So 1 minus 4, which is minus 3. Same way over here, it is 4 minus 6, which is minus 2. And 1 minus 6, which is minus 5. So you have D1, D2, D3. Now as usual, we are going to square D1, we are going to square D2, we are going to square D3. And find the total of d1 squared, d2 squared and d3 squared. Going on to our formulas. So r1 you find out with the help of d1 squared. Same way r2 you find out with d2 squared. So you have d2 squared and based on that r2, and then r3 is based on d3 squared. Now the ranks are found for the three judges. Since r2 is the highest, judge 2 and judge 3 are the pair of judges who have the nearest approach to common taste in beauty. Thank you and have a happy learning. Thank you.